All right, welcome to this presentation where we want to deal with the binomial expansion. Now, to start with, we can deal with the definition of a binomial. We are saying a binomial is an algebraic expression. It is an algebraic expression. Algebraic expression, take note, this is not their expression, containing two terms. So if an expression has got two terms with variables, that is an algebraic expression. All right, e.g. A plus B, that is a binomial. Now, we need to learn the concept of binomial expansion so that we are able to expand the powers of the binomial with less challenges. For example, if I say expand this, all right, using the ordinary multiplication, we are going to take a lot of time. We'll find the answer, but in the process, we can make errors. So because of that, we need to learn the concept of binomial expansion. Okay, so now we know, all of us, we know, or we agree that what is it that we know? That if we have a plus b to the power 0, this is equal to 1. If you have got a plus b to the power 1, this is equal to a plus b. If you have got a plus b to the power 2, if you expand that, you are going to get a squared plus 2ab plus b squared. We can introduce another one, a plus b to the power 3. This will produce a to the power 3 plus 3 a squared b plus 3a b squared plus b to the power 3. Now, if we continue this manner, we are going to identify something. So, now, isolating, if we were to isolate coefficients, we obtain the following. What is it that we are going to obtain? So you realize for the first one, we have got 1. So we obtain 1. And the coefficient of this one and that one is 1, 1. So that is the 1, 1 down. The next below, it is 1, 2, 1. Okay. This third row, we have got 1, 3, 3, 1. Now, if you see what is happening, what is it that that is happening? 1 is being maintained. But how are we getting these numbers? We are adding, like 2 to 1 to 2 get 3. 2 to 1 get 3. Meaning that the next one I have 1. 1 plus 3 you get 4. 3 plus 3 I've got 6. Here I've got 4, 1. All right? We can proceed. You can have 1. Here there'll be 5. You have got 10, 10, 5, 1. Then you have got 1, 6, 15, 20, 15, 6, 1. Then you have got 1, 7, 21, 35, 35, 21, 7, and 1. Now, when you look at this, you are producing a what? if you look at this, we are producing what we are calling a triangle. This is like a triangle, all right? And this note, this is what we call, this is called a Pascals triangle. So when people are talking about Pascals triangle, this is what they're talking about. Meaning that we can use a Pascals triangle to expand the powers of a binomial. All right, we can use the Pascals triangle to expand the powers of a binomial. Meaning that if you want to expand a binomial of this nature, x plus 1 maybe to the power 2, you are going to go to the law where you have got 2 appearing, which is this. We are going to use those coefficients. If you have got a plus b to the power 4, I'm going to go to this law where there is 4. The second number is 4 apart from 1. Okay? So you can write those coefficients in advance. Then you follow the other rules. Okay, so a binomial becomes handy in expanding. I mean, a Pascals triangle becomes very helpful in expanding binomials, unlike using the ordinary multiplication. Okay, so let's try to look at an example on how we can use this triangle to solve our problems. Okay, so I'll say expand the following. Binomials. A, you have got x minus 2 to the power 2, then b, 4 minus x to the power 5. All right, so answers. So to expand x minus 2 to the power 2, we need to use the coefficients. And in this case, since there's power 2, it means we are going to use these coefficients where there's 2 here. So we are going to use the coefficient of 1, 2, and 1. So we have got the coefficients are 1, 2, and 1. Okay, so this will be equal to the first one. It will be 1, open bracket. Then you get the terms inside the bracket here. There's x and negative 2. So the first one will be x, the first term, raised to the highest power, which is 2. Then the next term is negative 2, raised to the power 0, because the highest power, which is 2, has already been assigned to the first term. So plus the next coefficient is 2, but the first term is x. So now the power will reduce from 2 to 1. The other one will be assigned to the second term, so it will have got this. Plus the last term is 1. 1 x to the power, this will go to 0, then negative 2 will have 2. All right? So x to the power 2 is x squared. By 1, it will be x, c squared. Negative 2 to the power 0 is a 1. By x squared will be that. So we have got that. Then we are here. Okay, so we have got plus all right, so take note, negative 2 to the power 1 will be negative 2. So when you multiply by the signs here, the answer will be negative 2. So 2 by 2, that will be 4. By x, we have got 4x. All right? X squared, x to the power 0 is 1. By 1 is 1. Then negative 2 squared is positive 4. So I've got it 4. So this is your answer here. Okay? That is our answer. Now the second one is B. So we have got x, 4 minus x to the power 5. So the coefficients I'll use are 1, 5 from my triangle, 10, 10, 5, 1. So this implies that we have got 1, open bracket 4, the power 5 by negative x to the power 0 plus 5, 4 to the power 4, open bracket negative x to the power 1 plus 10, 4, the power reduced to 3, then negative x will have now 2, but the total number of powers should be maintained, plus another 10, 4 to the power 2, negative x will have power 3, plus 5, we have got 4 to the power 1, this is power 1, take note, open bracket negative x to the power 4, plus 1, 4 to the power 0, open bracket negative x to the power 5. What does this mean? What this means is that so negative x to the power 0 is a 1. So 1 by 4 to the power 5 is 4 to the power 5, by 1 is 4 to the power 5. So you need to find 4 to the power 5. So 4 to the power 5, we are going to get 1024. Now, the second term here, negative x is raised to the power 1, so the answer will be negative. So 4 to the power 4 times 5, we are going to get minus 1280 x. All right? Now look at x. Negative x is raised to the power 2, so to be positive. Then you say 4 to the power 3, 4 to the power 3 by 10. So we are going to get plus 640 x to the power 2. Then when you look at this one, the power is odd, so the answer should be negative. Then you say 4 to the power 2 is 16. 4 to the power 2 is 16 times 10. 4 to the power 2 is 16 by 10. I've got 160 x to the power 3. Here the power is even, so the sign will be positive. Then 4 to the power 1 is 4 by 5 is 20 x to the power 4. Then this will be a 0, it will be 1 minus, because this is the power is odd, so it will be x to the power 5. And this is your answer. Now, note, the powers of x here are ascending. All right? Here the powers of x are ascending. But the powers of x in the first example were descending, meaning that if you start with a variable, the powers will be descending. If you end with a variable, the powers will be ascending. Thank you so much for this presentation, for watching. Sorry for the noise in the background where I am. There's a bit of noise. Thank you, and please subscribe and share. This has been Phiri. You can reach me on 0978 56 58 76. Thank you. Till next time. Shalom, shalom.